Hey guys, and welcome back to the channel. This will be part 2 on the 5.7 Alpha Mercruiser from Maciej from Colorado. His original computer was not repairable, ended up being a bad microprocessor for those that have not seen the video. So what I ended up doing for him, it was finding a donor module and transfer his calibration, and now I'm going to do the test on that one. So I have both computers as you see here, and I'm going to show you in a second everything running. I will have the DICOM, which is the diagnostics for the boats. I'm going to have the meter and the picoscope, which is an oscilloscope that we can see the signal from the injectors and so on. All right, so let me move you over to there. All right, so let me put the meter, pico, and the DICOM. You can see the DICOM. Let me just check, make sure why the pico is not on yet. To reselect it every time. I don't know why. Try not to get the boom too much in your way. Let me move the data here so we can see everything. Looks like DICOM's a little caught up, so give me 1 second. All right, everything is good to go. So I'm going to disconnect from everything. I'm going to turn the actual computer off so you can see the fiber reference going. Sorry, that's actually running. Going away. You see now the meter going into 0. I'm going to turn the ignition back on. We got the 5 reference, and we see the voltage on the readings on the oscilloscope. I put the minimum and maximum kind of like switch up, but you can see the red and blue. Red is B channel and blue is A channel. Hopefully you can see that well. All right, let me go over to DICOM. I'm going to disconnect from what we have so you can see connection, and so is Maciej. That connects perfectly to his computer. So this is, let me see where I am right here. So we got to select Mercruiser 2001 to 2009 PCM and ECM555. That's what we have. This is an ECM5550202. Right, you can see it connects pretty much instantly. I'm going to go over to test just to show you the system information. This is, need to put another capture in here because otherwise you will not be seeing that. I'm glad I look into that. Yeah, it's showing a little bit in there, but let me move this. Oh, I see. So it has to go out. I'm going to put it, where can I put it? Well, for the meantime, I'm going to put it here. No matter what, it's going to be a short, just a short time so you can see that information. So what we see in there, I'm going to, again, disconnect one more time because I want you to see, and very important for him to see that that is indeed for his computer. So I'm going to disconnect, go back to here, reconnect. I'm going to close that window. So I'm going to click on exit, and you see that that one is gone. So I'm going to disconnect from the computer and reselect it. All right, connection went perfectly. Let me make sure that that is still on. Can I see it? Yes, it is on. I'm going over to test. You can see that is communication will be stopped, and that's just the requirement for Rinda to read that. Now we're going to read system information, and now it's being populated as you see live. And in there, you can see it's also giving us in there all the parameters from the computer, right? So at the top, it says O2 made 5.7 alpha. So that the calibration was made on May 02, 2002 May. And it's a 5.7 alpha. The ECM is at 859613. That's very unique to this 0202, right? And the calibration is A64272-3, which is exactly his calibration. I'm using his CSEN calibration. And the rest are just notes for technicians like me. Sorry. To read what the voltage should be. Let's say on the first one, it says, well, desired idle 600 RPM, throttle position sensor 0.22 to 0.9 at idle, and a watt open throttle for 4.07 to 4.83. So it's a wide range, but that is what, values that we can see in there. So, right. So Let's go back to the computer and reconnect. Now I'm going to read codes or history, right? I'm going to read the fault in RPM history. That is being populated. As you can see, that bar going across, that is the freeze frame data. That's way too bad to be populated. And we now going to see plausible information, because with his original computer, the information was going into zeros or 70,000 seconds. It was a completely error on the information. So I'm just going to scroll all the way down, because the main information we need here is this one. Total engine runtime, 292.2 hours. That it was the last recorded when I captured the calibration. And everything else is fine. So usually what I do, especially when I, repair or put a new calibration, or recalibrate a computer, I erase the fault history. So in here, you click on the H, and I erase the fault history. I never erase the RPM history unless the customer requires it. That's not going to erase the computer hours. It's just going to erase the RPM hours. Like in here, if you see on the bottom, it says it has 48 hours, 95.75 hours in 750 RPM, up to 1500 RPM, 48.2 hours. Those are the RPM history. All right, so when I click in erase in here, now it's going to erase that. So if we read, again, the fault and RPM history, we should now have no fault history as far as, that the pitted and other faults that are always going to show up. But no more of that horn output or any of the nonsense that we had before. All the overheating and all the faults are gone, but the hours stay intact. When I tried to do this on his, after the repairs, the hours of the computer went to zero, that's not right. When something like that happens, they immediately tell me inside of me, you know what, we might have a problem with this computer. And finally, after running it, it cropped out. It went completely to no start. I was able to make it run again, but it was definitely no good. And I tell him, Maciej, this is a never-ending situation. The best thing to do here is find another computer. And I'm glad that he follow my lead. All right, so let's run this. Okay, so we got everything ready to go. I have the RPMs ready. Okay, now you can see bank 1 and bank B of injectors on the oscilloscope up in the tab. Again, the minimum and maximum should be battery voltage to almost 0 volts, and we can see that happening perfectly. The computer is showing 100% available power, which is great. And it might go over to 90% when I raise the RPM, because it's suspecting to have a knock sensor. And that is very common on this one, but it already actually did it. And if I read the fault codes, I guarantee you that the fault code is going to be for a knock sensor. Let me see, come on. Don't make me a lie right there. Okay, now we have the first one up in the tab. It says knock sensor 1 code active. Why? Because I don't have it connected. And I always leave that unplugged just to make sure that the logic on the computer is reading properly. And I don't need it for running in here because it's not going to affect my test. Another reason why I don't use it, because it's not a major player. It's a major player on the boat because it's going to retard the ignition in case of knocking, but that's it. But for me here, I am in complete control of everything, so that's not going to affect absolutely nothing. All right, so I'm going to move one of the channels over to the EST signal. This computer has one EST signal for the distributor, and that's the signal now we see on the red channel. It's a small signal. Why? Because we can see the amplitude in there. It's a 4 volts, a 0 to 4 volts, and that's what I put those measurements in there, right? So you can see the amplitude of the waveform, but everything is working good. All right, so let me raise the RPM. I'm going to go over to around 4,000 RPM, 3,500 to 4,000. Everything is very nice and very smooth. I'm going to change the throttle accordingly, around 40% throttle. And I'm going to change the manifold air pressure to around 14, 15. Oh, actually, this is in PSI, so I'm going to go around 12 PSI. That's going to change the injection millisecond, and we can see that on the blue channel, how now it's very wide. Why? Because I'm changing the map sensor. If I go back, you can see how that signal is going to change, And the map is in complete control. The manifold air pressure is in complete control of your injection millisecond. That's how the computer calculates the injection on this air density motors, right? But yeah, so I have very good news. I'm very happy to have found, because this computer had only 50 hours. So this computer is almost brand new. I did completely refurbish and change all the drivers and everything, because this is still a 2002. But it was a very not used computer, very nice, very clean, no problems. And we can see it here. So everything is nice and good to go. All right, so Maciej already approved the repairs. He already paid forward, and he's actually, I think he's out of the country. But he is expecting me to let him know, because he wants to have the boat ready, because family's coming for July. You know what is, everybody is trying to be on the water for those days. And you definitely will, and you will definitely enjoy your boat. All right, guys, thank you so much. If you have a computer, marine, or automotive that you need to repair, please just look for my website, the same name as in my YouTube channel here, Mike Salazar Diagnostics, MAIC SalazarDiagnostics.com. That is how you find me. If you're here and you have not subscribed, please help me with the subscription, because when you subscribe, it's for free. YouTube promote more my videos to others, and that's how you find me, so that will really, really help my small business. I would really appreciate if you do so. And if you do, blessings. Thank you so much. I'll see you all next time. Bye-bye.